So, talking about bidirectional associative memory, let's do one numerical where we are having two letters E and H, right? And we are given with its target codes. Target codes are given to us -1 1 for E and 1 1 for H, right? And we have to find out the weight matrix for it. So whenever we have to find out the weight matrix for it, it is given to us that this is a pattern E and this is a pattern H. Then how we will compute or how we will get that what will be the input for it. It will be done like this. This asterisk, we will combine all these asterisks and see it will make E. These asterisks are making H. These dots are the blanks, which means the value is -1, right? Because we are dealing with the bipolar vectors here. So wherever the asterisk is there, that value we have to take as a 1. And where we are having dots, we have to take these value as -1, right? So following this, we will get the input vectors for E and H like this. This is 1, 1. Then this is 1, -1, -1. This is 1, 1, 1. This is 1, -1, -1, 1, 1, 1, right? So in this way, we are getting the complete input vector for alphabet E, right? And for the target code, which is given to us, it is given to us -1, 1. Right? So it will be the -1, 1. Now, as per the requirement, we have to compute W1, right? In the same way, for H, it will be 1, -1, 1, 1, -1, 1, 1, 1, 1, 1, -1, 1, 1, -1, 1, right? So we are getting here the same way as the asterisks and dots are having the combination over there in the pattern, right? So this is the target codes for the alphabet H. Now, again, we have to find out the weight for the alphabet H or the pattern H, right? So moving further, what we have to do, moving further after doing it, we have to first of all find out the weight of pattern E, right? First pattern E. So W1 will be the complete vector of E, the input vector of E that we are having, right, into the target vector, right? So as per the bidirectional associated memory, the algorithm, we have to take the summation of all the source target, that we have to perform the transpose of source and the target pattern, right? We have to perform the transpose of it. So this is a vector of pattern E we have transposed it. This is the output pattern we are having. We will just perform the dot production of all these values and take the summation of them, right? And so we will get this as the value, right? 1, -1, -1, right? 1, 1, 1, then 1, -1, 1, -1, -1, 1, 1, 1, right? In this way, we are getting this 15 into 2 vector, right? After applying this particular algorithm rule. Now, in the same way, we have to find out the weight 2. That is the weight for the second pattern, that is H, right? So this is the W2 we have. This is the input vector of H we are having. This is the output or we can say target code we are having for the H. And whenever we are performing this particular formula in it, we are getting this as a matrix, right? So this is again a 15 by 2 matrix we have obtained, right? And now we have to find out the total weight. So what will be the total weight we have? That will be the summation of both the weights, W1 and W2, right? So we have to add both the weights we have with us, right? So after that, after adding both the weights, we are getting this as a 0 to 0 to -2, 0, this as a total weight matrix W, right? So this is what we have, how we have computed the weight matrix of the pattern E and H, right? We have to first of all get the input vector ourselves, and then we have to perform, we have to just remember this formula, that this is the formula that we have to perform, and then we have to add them, and we're getting this complete matrix W. Now, the second thing, the second task in this numerical that we have to do, we have to test. We have to test our bidirectional memory network with the input pattern E, right? So, as per the algorithm, when we have to perform the testing, we should memorize Y is equal to, Y means the output vector is equal to the input vector and the weight matrix, right? So this is the input matrix for E we have, and this is a weight matrix that we have just computed, right? We have to just perform the dot product of it, and we are getting this as a matrix, right? So whenever we are performing dot matrix of this, with it we are getting this, right? For example, 1 into 0, 0, then 1 into -2, -2, 1 into 0, 0, 1 into 0, 0, 1 into 0, 0, -1 into 0, 0, right? -1 into 2, -2, right? In this way, we are getting here -2, -2, -2, -2, because we are having only 4 values which are non-zero in this one. So that's why we are getting here only these values. Here, again, we have to find out the dot product of it. So 1 into 2, 2, right? 1 into 0, 0, 1 into 2, 2, right? And then again 1 into 2, 2, right? So we are getting 2 plus 2 plus 2 plus 2, 11, right? 11 times 2 we have to add, right? Because we have 11 non-zero values here, right? So after calculating it, we are getting -8 and 20, right? Now, by applying bipolar activation function, what we are getting? Minus value means it will gives us -1. And if it is a positive value, then it means it is a 1. So it has been proved that it is a correct response for E, because it was the target code given to us earlier, and that we have computed here by applying by taking the dot product with the of weight and the input, right? So in this way, in the same way, we can find out we can test the bidirectional associative network that we have just got with the input pattern H, right? The same procedure will be done for the H. We have to take the input vector for H here, and we have to multiply it with the weight, and we'll get in the same way, right? So this is the way how we can get the weight matrix, and we can test those values, right?